Welcome back to a new video, and this is my first cybersecurity plan. So, according to what ChatGPT gave me, he said your 30 days cybersecurity starting plan window. So, daily commitment, 2 hours daily slash day. So, no rush, consistent win. So, week one, computer and internet basic. You get now. So now the goal is to understand how computer and the internet works, what to do daily 2 hours. Like that means I really don't have to like okay, just be the guru of the whole day because even myself and please okay, I'll be doing some stuff. Trust me. Funny to some people but not to everybody though. Do you get now? So since they have given me he said the resource now understand how the computer works, how understand how computer and the internet works. So what to do daily, 2 hours, 1 hour, watch video. That means now. So the present time presently, what is the time? Currently we are this is 2:07 Monday morning. So 2:07 Monday morning and the resource is YouTube because most empower we use YouTube to what to do most of the work online. Na YouTube I go learn most of dis stuff. So and please let's begin. So the resources what how the internet works, YouTube, computer basic that's um um okay. So at the end of the day you should know IP address, server and browser. So week two Linux basic no installing. So let's say just basic transformer. So I think I get how to do it now. Okay. In week three, networking basic. Oh, ethical hacking and introduction. TICO study template. Use yourself now. Say no hacking real website. That means there are rules and regulations to follow, which means okay, we are good to go do. So after 30 days, you understand about describe basic. Use Linux confidently, understand networks, solve beginning hacking lab, know exactly what to study next. So next month, so we don't jump. So the number one now, this is the video. Open your Chrome, great. I think I do that. I've done create this account. This is it here. But let's talk about the video first because now the video should be cool. Okay, self check that. Okay, watch and learn, beginner friendly, how the internet work. Code cap. I think I showed you on the last video I did that this is where I will get some video too. Like I'm not running into programming language for now because I just have to start from the basic and there are things to do so that I won't get lost. So now so meanwhile watching write short note on what the internet what is the internet, what is an IP address. So I can't show you the note, but let's just say in compilation I will just like I open Google Doc for people that know Google Doc now. People Google doc Google document. So I think I'll be that's where I will put some of the stuff I will be doing into. So because I can't just keep on if I should write. Writing is good though. The more you write, the more you understand things. But let's put it there. I'm not getting it for them yet. So I think should we start? Okay, self-check important. Answer those in your own word. What is the internet? So after the video, I will I will do what the store is telling me. Okay, so let's stop and let's start. So start with the video. So and again, keep this in mind. Um, uh, I will not watch video the way you watch it because for now, I think I will do it max is 30 minutes. And should I set 30 minutes to stop time watch? Like 30 minutes. That you feel thing I understand and what I really don't get there. So the way I watch a video is 2 times. So in case of when you get here, you have to slow it 2 times. But once I'm done with the video, I will drop the full link here as well. Like I'll drop the full link of the video, but I won't drop it at first. Keep that in mind. So now let's start with the video. Mm, okay, just checking. Don't mind me, go back. So
The internet is a part of our daily life and we use it constantly. But what is the internet? Have you ever really thought about it? Have you ever wondered what happens in the background when you enter a web page? If your answer to all, I assume you don't know anything, and I am slowly explaining what the internet is. You don't need any prior knowledge to follow this course, since this course tells you everything from scratch with many abstractions. These abstractions will allow you to understand the subject without knowing details. I think everyone who uses the internet should know its basic features. Everyone who uses the internet needs to know the ISP. Everyone who uses the internet needs to know that the internet is just cables spread all over the world, and in this course we will go on a journey together and we will look at all these concepts in a very visual way. I mean, you will see exactly how the internet works with your eyes. In addition, at the end of the course, there are some questions related to this course, and by answering them, you can benefit from this course at the maximum level, okay? Regardless of your age or profession, this course is for everyone. You will absolutely understand what the internet is when you finish this course. So, let's dive into it. Now, we are going to talk about a scenario. Let's say you are the system administrator of a small company and your boss wants you to enable all these computers to communicate with each other. I mean, PC1 should be able to communicate with PC7, or PC5 should be able to communicate with PC4, and so on. You got the point, but the question is, how do we do such a task? And this is where the switch device comes into play. The switch is the device we use for computers in the same environment to communicate with each other. When I say in the same environment, what I mean is that I am talking about computers in the same office, house, or at very close distance to each other. And this scenario is a good example for such a situation. There's an office, and in this office we have 7 computers that communication of them is required. Wonderful. We have a switch to accomplish the communication of computers. This is good. However, the question is, can these 7 computers communicate with each other right now? And the answer is big no. Because first of all, these 7 computers need to interact with the switch somehow. But how can we do that? I know that you have some ideas, and you are probably guessing right. We must use cables to connect computers to the switch. As you can see, we are connecting all the computers to the switch with the help of cables. We generally use copper cables for this task, and the type of these copper cables can generally be Cat5 cable or Cat6 cable in small environments. By the way, Cat6 cables are faster than Cat5 cables, and Cat represents category, okay? On the other hand, in addition to copper cables, some switches support fiber optic cables as well, and it is important to note that fiber optic cables are generally much faster compared to copper cables in data transmission. This is very important. And for switch devices, there is a crucial point to be aware of. Please note that if there's a switch in the environment, and if we want to connect computers to that switch, we must definitely use a cable that is generally a copper cable or fiber optic cable. What I am trying to say is, with wireless technology, you cannot connect computers to a switch. Switches only work with cables. This is very vital, guys. If you want to use a switch device, you have to use cable to connect your devices to the switch. It's that simple. However, if you want to connect computers in the same environment to each other by using only wireless technology, you can use an access point device instead of a switch device. I mean, you can use both a switch device or an access point device in order to connect all the 7 computers. Both of them separately is acceptable for this purpose. The only difference between these devices is access points use wireless technology while switches use cables, okay? There are 7 computers in this environment, and we can connect these 7 computers by using switches and cables, just like you see in the picture. Or in the same way, we can use an access point device instead of a switch device, and if we use an access point device, access point uses wireless technology instead of cables while communicating with devices. In summary, both the switch device or an access point device enable these 7 computers to communicate. This is obvious, but one uses cable and the other one uses wireless technology. Anyway, what I just want you to know right now is we generally use copper cables in order to connect computers to the switch in the environment such as a home or office. By the way, I want to focus on the switch device instead of the access point device in this course. Very good. And at this moment, all these computers can communicate with each other with ease because they connected to the switch by using cables, and this means that they created a network. In other words, the reason that these computers can communicate with each other is all of them are in the same network, and we call this special network as local area network, or briefly LAN. A local area network is a collection of devices connected together in one physical location, such as a building, office, or home. As I just said, if we want to create a LAN, this location must be a restricted location in terms of area. I mean, you cannot create a LAN between computers located in United States and computers located in Russia. On the other hand, this area is very suitable area in order to create a LAN. Therefore, these computers can communicate with each other because all of them are on the same LAN with the help of this switch. So, we can deduce that if we want to create a LAN, we need a switch device. By using a switch device, we can create a local area network. And if we consider the millions of local area network all over the world, we can easily understand how important a switch device is. You might think that all the houses in the world are actually a local area network. You have a LAN in your house, or your neighbor's home also has a LAN, or there is also a LAN in the office where you work, okay? You catch the idea. And now, let's take a closer look at the communication of computers and what this event actually represents. Let's say PC1 wants to send a message to the PC6. By the way, the messages generated by computers has a few special names. Some people call them as packet, and some people call them as frame. Both of them is okay, but in this course, I prefer to use packet instead of frame. Okay, PC1 will send a packet to the PC6. As you see in the visual, the packet firstly goes to the switch, and then the switch looks at the inside of the packet and learns the destination of the packet. And finally, the switch sends the packet to its destination. And if PC1 can send a packet to the PC6, this means that PC1 and PC6 can communicate with each other. The logic is basically this. If a computer can send a packet to another computer, this refers to these two computers are on the same network and they can communicate with each other. This information is so crucial, guys, okay? However, maybe by looking at only this switch image, what the switch device actually is may not be fully visualized in your mind. For this reason, we will now examine this slide for you to understand the event better. This is the real version of a switch device, and as you can see, there are many ports on a switch device. This is important. Also, the number of ports varies from one switch device to another switch device. I mean, different switches have different numbers of ports. Some switches have 10 ports, while some switches have more than 20 ports. And of course, this generally leads to an increase in price. Okay? By the way, these ports have a special name and they are called LAN ports. This probably makes sense to you because, as you know, we create LANs by using switch devices. For this reason, I think it is so reasonable to call these ports LAN ports because by connecting these computers to these ports, we can create a LAN. And in addition to this, there are LAN ports on the back of our computers or on the side of our laptops, just like these LAN ports. You can see the related visuals on the right side. And to establish a connection between computers and the switch, we connect the LAN port on the computer and the LAN port on the switch with the help of a cable. So, let's do this. Let's start with this port and PC1. Then, let's connect this port and PC2. After that, let's connect this port and PC3. And finally, I want to make a connection between this port and PC4. Wonderful. And currently, these computers can communicate with each other. But how exactly does this communication happen from a switch perspective? Let's take a look at this. Let's say PC1 wants to communicate with PC4, so it will send a packet to the PC4. This packet will go to this port of the switch first, and there we go. Afterward, that port will give the packet to the hardware inside the switch, okay? Then, the switch will look inside this packet and learns its destination. After that, the switch gives this packet to this port that is connected to PC4. And finally, the switch sends the packet to the PC4. Okay? Wonderful. And to summarize, currently, we have connected these four computers to each other thanks to this switch. This means we have created a local area network and these computers can easily communicate with each other since they are on the same LAN. I hope everything is quite good so far, and the switch device is visualized better in your mind thanks to this slide. But there is a little issue here. Let me explain. If you are aware, our computers were in the same network, and we have only talked about the communication between those devices. We have never talked about how these computers can connect to the internet, right? So the question is, can these computers communicate with the internet just by having a switch device? And this, my friends, will be the question that we are looking for an answer in the next lesson. See you guys soon. Bye. In our previous lesson, we briefly talked about how to connect computers in an office and how do we create a network. And I said that we can create a LAN with the help of a switch device. But the problem is, currently these computers can only communicate among themselves. They cannot communicate with the internet because the only task of the switch is to create a LAN and enable the communication of the devices in the same LAN. Great. And by the way, I would like to remove this LAN statement from the visual because you can understand that there is a LAN here. Thus, we can work more comfortably. Wonderful. And the main question is, how do we connect these computers to the internet? And this is where the router device comes into play. Let me explain. The main task of the router is to enable computers to connect to the internet. Without a router, it is impossible for us to connect to the internet. And in order to provide this connection, in order to provide a connection to the internet, first of all, we must connect this switch to this router. And this cable is a copper cable, just like other cables. This is good, but currently, what we have to do isn't over. We still can't connect to the internet in this situation, because we need a connection between the router and the internet as well. And as you know, a special cable comes to our homes or offices, and this cable is given us by internet service provider. And thanks to this cable, we connect to the internet. If you have never heard of internet service provider, don't worry, we will talk about it in detail. But for now, all you need to know is the internet service provider is giving us this cable for a certain amount of money so that we can connect to the internet easily, okay? So currently, we have everything necessary to connect to the internet by using these computers. Hence, let's see the basic tasks of the switch and the router one by one on the animation. These 7 computers in the office can communicate with each other thanks to the switch. For example, let's say PC1 wants to communicate with PC5. For this purpose, PC1 will send a packet to the PC5. So, as you know, the packet firstly goes to the switch, and afterward, the switch learns the destination of the packet, and finally, the switch sends the packet to its destination, and there we go. This is how 2 computers in the same LAN communicate with each other. And please, always remember, a switch device is enough for us in order for communication of devices in the same LAN. On the other hand, a router has no role in the communication of different devices in the same LAN like PC1 and PC5. This is very vital, okay? I hope I could explain the event. And however guys, what if PC1 wants to communicate with the internet? In other words, what will happen if PC1 wants to send a packet to the internet? Let's see. First of all, you should remember this information. If a computer can send packets to the internet, this means that this computer communicates with the internet. Frankly speaking, I believe that you exactly understand the logic of this event anymore. If we can send packets from one point to another point, these 2 points can communicate. It's that simple. But the question is, how will PC1 send packets to the internet? To be able to do this, first, PC1 must send its packet to the switch just like before, because there is no other way for PC1 to be able to reach the router, right? If PC1 wants to send a packet to the internet, this packet must reach the router no matter what, because the router is a door to access the internet. This is obvious. Hence, if PC1 wants to communicate with the router, it must send its packet to the switch first. After that, the switch looks at inside of the packet and understands that the packet wants to go to the internet. So, it sends the packet to the router, and there we go. And then, the router firstly looks at the inside of the packet and understands that the packet wants to go to the internet. And afterward, it sends the packet to the internet over this port. And there we go. By the way, if you are aware, we have plugged this cable that we purchased from the ISP into this port. This is obvious. I believe that currently you can easily imagine in an intuitive manner how the cables coming to the router like this or like this are plugged into the ports. There are some ports on the router and you need to put the cables into that ports. It's that simple. I will not show this visually because detailed information about the ports isn't important for you at this moment. You just must understand the logic behind the router, okay? And as a result, PC1 sent its packet to the internet. In other words, PC1 and the internet communicated. And the device that helps us to connect to the internet is the router. Wonderful. I believe that you understand the most basic tasks of the switch and the router, and I hope the animations have been useful for better understanding. However, I want to ask you 2 questions. My first question is, can you visualize the internet in your mind. And the second question is, what exactly does the internet mean? And these will be the questions that we are going to discuss in the next lessons. See you guys soon.
So according to what is said now, according to what he said now, he said router. Like if we can visualize the internet in our wide, and what does the internet even looks like for me? That's a wonderful question. My question now goes to router. I think router is MiFi in Nigeria, right? Or Starlink. I think we can classify router as Starlink in Nigeria. Or or I think we have normal router, all those M10 big MiFi. I think that's what. I'm not sure, but this is still our first video, right? So we just keep on with the knowledge. So I will play the video now to continue where we stops. And so to continue where we stops, and let's keep on finding out what the internet really looks like.
Before discussing the meaning of connecting to the internet from a computer perspective, I think it is helpful to know what the internet exactly stands for, because if you are really starting from scratch, I assume that you are real newbies, you may not know exactly what the internet is. For this reason, I want to visualize the internet for better understanding. To do this, in this lesson, we are going to see how a packet moves on the internet. By the way, keep in mind that this model you see is a simplified model designed to make the concept easy to understand. So, this structure in real life is much more complex than you see in the visual. But with this simplified model, you will understand the logic of the event very well, I promise you. And I believe that's all you need right now. As you can see, there are many routers on the internet, right? And there is a special reason for this. So at this moment, I would like to give you another piece of information about a router. A router is a device required for a computer or electronic device to connect to the internet. You know this definition. On the other hand, you can think of the router as the device we use to communicate with a computer in another part of the world, or you can think of the router as the device we use to communicate with a computer in a different LAN. If you are aware, there is a LAN here, right? And there is another LAN here. This is obvious. Therefore, we can draw the following conclusion. Connecting to the internet actually can stand for connecting to another computer located anywhere in the world. You can think of the internet as the structure that connects all the LANs all over the world. I want to repeat this again. You can think of the internet as a structure that connects all the LANs all over the world. And as you know, there are millions of LANs connected to the internet except these LANs. Wonderful. I hope that everything is good so far, but there's a thing that we need to consider. So, I want to ask you a question. Why are there so many routers here? Let me explain it in a simple manner. First, you should know that these routers are distributed around the world in an organized manner. However, routers aren't the only devices in this structure. This is important. There are thousands of routers and other different devices in this structure distributed pretty widely. But focusing on only routers is enough for us in order to understand the concept behind the internet. And the first question that comes to your mind is probably why routers are so important to the internet. As a matter of fact, the answer to this question is hidden in the core task of a router. The device we use to enable different LANs to communicate with each other is the router, right? And thanks to the internet, we can connect all the LANs in the world to each other, For this reason, it makes perfect sense to use many routers to connect millions of local area networks together. These LANs, you see, are just two of the millions of local area networks all over the world. In summary, if the internet must connect millions of local area networks, it is obvious that it needs routers. I hope You got this. And once you understand the importance of the router for the internet, you probably think of another question. And the second question that probably comes to your mind is why there are so many routers instead of just one router. And I think this is a more critical question than the first question, and let me answer it on the visual. But before answering this question, there is something in this picture that should catch your attention. Please look carefully at the picture and try to find this difference.
Giant router. That's the difference. It's connected to the internet. All of them connected to the internet.
As you can see, these LANs on the visual have one device instead of a switch and a router. So, if there is no switch in the environment, how can there be a LAN? Or, if there is no router in the environment, how can it be connected to the internet? And this is where the home router comes into play. A home router is a combo device consisting of a router and switch combination. Hence, these devices in the LANs are a mix of the switch and the router. This means that if we have a home router, we don't need an additional switch and router. This device is enough for small environments like a home or small office. This is important. I want to repeat this again. A home router is enough for us in small environments, or if there are very few devices in the environment. Okay? I showed you home router because most of you have these devices in your home and you connect to the internet by using home routers. For this reason, I wanted to tell you what these devices are in order to avoid confusion. However, please note that if there are too many devices in the environment, the home router will be insufficient and you may need additional switch and router. You catch the idea. And now, let's go back to our question. Why there are so many routers instead of just a single router? Imagine that there is a single router in the middle of the world instead of thousands of routers distributed all over the world. In this case, millions of electronic devices around the world would have to be connected to the same router. This is obvious. This means that this single router needs millions of ports, isn't it? And it is impossible to design such a device. But this is not the only problem. In addition to it, if there was only one router, the entire lot of the all devices in the world would be on that router. And this is another problem because in computer science, we don't want to give all the load on a single point. We even call this problem the single point of failure. And this is a problem that needs to be considered. To be able to teach it better, let me give you an example. Imagine this router is broken somehow. This means that the internet of the whole world is crashing down at the same time, right? Because we only use a single router to connect all LANs around the world. The router broke down and the whole internet crashed down. It's that simple. Just think about the consequences of this problem in a second. This would be terrible, right? And so far, we have talked about two vital problems, but it isn't over. Another major problem is the cable length problem. Imagine how long the cable must be if there was only one giant router in the middle of the world. Especially LANs that are the furthest from the giant router will need very long cables. This is obvious, right? Therefore, this design is a very problematic design. And the solution for all these problems is this distributed structure all over the world. You catch the idea. But to make sure you fully understand the main logic of this structure, I want you to do an exercise. I want you to determine why such a structure eliminates the problems we talked about shortly before. I'm sure that you can handle this. Just do it, guys. I asked you a question at the end of the previous lesson, and I know that you were all analyzing the situation, but let's do it together just in case. As you know, if we used a single router at the middle of the world, we would have problems with the overloading of the router. On the other hand, we would need many long cables for LANs that are the furthest from the giant router. But as you can see in this structure, the cables don't have to be that long, and this is an important advantage. Actually, Of course, we can need long cables in this structure too, but not as much as in the other structure. After all, in this structure, there can be many kilometers between two routers. This is reasonable. However, this is by no means laying cables from one end of the world to the other end, right? And while we only connect two routers with one cable in this structure, we will connect millions of LANs to the giant router in the other structure. So, we will need a lot of very long cables to a single point. And it creates a huge mess. Imagine cables coming to the giant router from millions of LANs that locate in the furthest area. You got the point. By using this structure, we minimize the cable mess and we avoid overloading of a router. Everything is good, but what about the load overloading? Since there are many routers, load balance process is very efficient in the distributed structure. I mean, this system works very well. And in addition to load balancing, it solves the single point of failure problem as well. For example, this router, this router, this router and this router are broken somehow. In this case, the internet continues to work properly, right? Only its efficiency decreases a bit. On the other hand, when there is only one router and if this router is broken, the whole internet crashes down and this was very bad. So, I believe that consistency is very important for such a huge structure like the internet. And now, I want to show you a visual that shows the cables between different countries and different continents. With this visual, you will understand much better what the internet is. These cables are very important, especially for the communication of countries that there is an ocean between them. And this visual represents real life itself, unlike the simplified model we use. 99% of all international communication on the internet is provided by these 468 cable lines laid under the water. This is very crucial, guys. Some of these cables are only 131 kilometers long, while others are around 20,000 kilometers long, and so on. And the funny thing is, breaking one of these cables can cause the internet of a whole continent to go away in a flash time. In fact, it was happened such an event in 2018, and I want to show this on a different image, okay? I want you to focus on this red cable. This is an almost 17,000 long cable that starts in France and reaches South Africa. And this cable connects 22 countries on the west coast of Europe and Africa to each other and to the internet. And the internet of 10 of these countries crashed down when a fishing boat accidentally cut the cable, and I think this was a definitely tragicomic event. In addition to this, as you can imagine, this is not the only problem that happens to cables, because we are talking about 1 million kilometer long cables spread all over the world, so there must be something more. As a matter of fact, nearly 200 problems are encountered each year, and these are substantially related to the ships or natural disasters. And there is a funny reason that I prefer to use substantially word. Let me explain. In 2007, sea pirates stole 11 kilometers of a cable connecting Thailand, Vietnam and Hong Kong to each other. And they sold this long cable as scrap by dividing it. And I think this event is more surprising than the incredible infrastructure of the internet. Now, I have back to the first slide because there is something I want to show here. These colorful cables generally represent intercontinental connections under waters. But for example, if you look at Russia land, cables are not visible on this image. Please don't be confused about it. Of course, there are cables and routers distributed all over Russia too. They are just ignored in this image. I mean, the main purpose of this image was to show you how devices from different continents are interconnected under the water, okay? Also note that all of these cables under waters are fiber optic cables because the fastest data transmission cable type is fiber optic cables, and intercontinental data transmission must occur at the highest speed, right? And another reason of why we don't use copper cables is when the length of the copper cables increases, the probability of errors in data transmission increases as well. On the other hand, even if the fiber optic cables are very long, they transmit the data to its destination almost without error. And this is another reason that why fiber optic cables are used over long distances. Great. I think it is important for you to understand what the internet really is. It is very vital to be able to visualize it in your mind. Because no matter what area of IT you are dealing with, you need to grasp this basic subject. Actually, there was something else I wanted to show in this lesson, but I don't want to extend this lesson any further. We will continue where we left off in the next lesson. That will be a very important lesson. See you guys in a moment.
So let me check. Hmm, almost an hour. Almost an hour. And I'm sure not everybody will be so not everybody will should I say not everybody will watch it the way I watch it. But let's just say, at the beginning, I first fast forward the video, but and I think about it, maybe like, okay, you have to reduce it to at least not everybody watch video times two faster as I do. So that's why I slow it down a little bit so that we can all understand it the way it goes. And I wrote down few things here, which is the first one, which is what is the switch and why do we need it? I think to my own understanding, that switch looks like our router because according to what you say, or what should I say? That router looks like our normal Wi-Fi here, like all those, router, Wi-Fi, Starlink stuff, everything. And the second one, which is the switch, you say the switch is a category of five, six, something like that. Yeah. So and the one is which I was also interested is the LAN, which is the local area network. I think that's LAN. And the last one, which is what is the router? I think the router himself is the machine that provide internet. But we here we provide data, but I still don't get the full details. But as we go, we continue. Do you get it? So I do it 30 minutes video. So I don't want to rush it because on my own end is more than that 30 minutes. But see you guys on the next video. And don't forget what I always said. The highest thing you can ever do for me presently is just to like the video. On my next video, and if you find value, I believe with time, if you if you are finding value in what I'm posting, don't forget to what to also subscribe. See you guys on the next video.